Hi guys, I am recording what we did in class today. We were in school, but a lot of you were out with the ACT stuff that was going on. And so I'm going to go over quantum numbers. Now this is not going to be a detailed explanation of what quantum numbers are and where they come from and all of that. This is just a very simplistic version of how to come up with the 4 quantum numbers for each electron in an atom or ion or whatever we're working on. Alright, so a real quick review. If we were to look, let's say, at oxygen and the electron configuration, I'm not going to write out the whole thing. I'll just write out the very last bit of it, is a 2p4, and its orbital notation is something that looks like this. It's a 2p bracket, 1, 2, 3, 4 electrons. So we use both of these to help us count our electrons. Right? We learned that we're counting electrons and so on and so forth. They both do that. However, in this notation, it just tells us in the 2p we have 4 electrons, whereas in this notation it's a little bit more specific because it shows us where within the 2p sublevel those electrons are located, and specifically which orbitals. Now, what we are going to do is we are going to assign numbers to each one of these electrons that helps us see and know where the electrons actually are. Alright, so here we go. First thing you're going to need to do quantum numbers is you really need, I mean, once you get really used to it, I guess maybe you don't have to have it, but for right now you guys need to draw out the orbital notation. For now. Once you become like awesome, you might be able to skip that step, but for now you really need to do it. Alright, and there's another little thing that you need to know, and that is that every electron has its own unique set of quantum numbers. Okay? And there are 4 quantum numbers. Alright, so this is where I'm going to get somewhat simplistic, and when I'm talking to you, you might think it's not very simplistic, that it's confusing, but really I am oversimplifying right now for how to determine what the quantum numbers are. Like, I just wanted to be very specific that this in no way is an explanation of what quantum numbers are or where they come from and so on and so forth. Alright, so the first one, quantum number 1, is called the principal. And that is spelled like the principal in a school. Quantum number. Okay, the principal quantum number. Alright, it is represented by a lowercase n. Now this should be familiar to you because we have worked with lowercase n before, and that refers to energy level. It's the same here. So when we say principal quantum number, what I need you to think in your brain is energy level. Okay, this is our energy level, which, if you recall, the energy level correlates with these coefficient values for oxygen 2. This is your energy level here. Alright, so this is N. Okay? So principal quantum number is the energy level. Alright, number 2, the angular momentum number. Alright, this is sort of it's definitely a lowercase cursive L. It's sort of somewhat italicized. Alright, but it's a lowercase cursive L. Again, this phrase sounds very confusing, like I'm totally speaking another language to you, and that is totally normal. And it is like speaking another language, so when you hear angular momentum, hear it, but I want you to process that in your brain as the sublevel. Right, and we know that our sublevels consist of letters. They're S, P, D, and F. And we aren't going to go into the imaginary sublevels of G and H and so on and so forth. Now, this right here says that this should be a number, not a letter. So scientists assigned numbers to each of these sublevels. We started with the first number that we start with, which is not 1, it's actually 0. So S is assigned the number 0, P is a 1, D is a 2, and F is a 3. Alright, so these are your numbers that you assign to your sublevels. Alright, number 3, the magnetic quantum number. And it is an M with a subscript L. So the L is still referring to what's going on within the sublevel. That's why it's there. So the magnetic quantum number is actually going to tell us where within that sublevel it is located. The electron is located, because that's what we're talking about, is our electrons. Alright, so for this one, I want you to think, or like I said, it's like a foreign language. When you hear the magnetic quantum number or the third quantum number, I want you to think in your brain of a number line. Think of a number line. And you guys know that right smack dab in the middle of the number line is 0. If you know that, then this should not be that difficult. Alright, so I'm going to run through each one of your sublevels for you very quickly and assign them number line numbers. If I'm going too fast, then pause and slow it down. Alright, so if we have an S, every S has one orbital, one line. That means that the number that I would assign to smack dab in the middle, that's my starting point, is 0. There are no other orbitals in an S. Every single S, doesn't matter which one it is, has one orbital, which means that its number line number is 0. Alright, so then we have our P. 1, 2, 3, P. Smack dab in the middle of all number lines is 0. Go to the right one and that's +1. Go to the left one and that's -1. Wherever your electron is located within the orbital, this would be the number that we would assign to them. Hang on. Alright, sorry, I was getting some alert on my thing driving me nuts. Alright, so here we go. D, we have 5. 1, 2, 3, 4, 5. This is my D sublevel. Again, if you have an electron in the D, the middle orbital is your 0, +1, +2, -1, -2. It's not rocket science, we got this part, this is easy. Alright, F. F, we have 7 orbitals. Right in the middle is 0, 1, 2, 3, -1, -2, -3. Okay, so if you are an electron, you're speaking about electron in any of these individual orbitals, then you need to think back to this right here to think of what number to assign them based upon their location within their sublevel. Alright, number 4 is going to be the spin quantum number. Alright, it is also it's a lowercase m. In this case, it's a subscript s for spin. Now, every orbital may hold a maximum of 2 electrons. We've been talking about that. 2 electrons. But when we're doing our quantum numbers, we're only speaking of 1 electron. So we're speaking 1 of the 2 electrons in an orbital. So if I'm speaking of 1 of 2, then the fraction for that is 1/2. And you guys know that the first electrons we put in spin up, so it's an upwards arrow. And the second electron that goes into an orbital is a downward spinning arrow. So we have arbitrarily just gone along with what your math teachers teach you, which is anything that's like, think of these arrows as being in the y-axis. Anything pointing up or going up in the y-axis is a positive 1/2, and anything pointing or going down in the y-axis is a negative 1/2. Okay, so this is what we assign. I do need to see this plus 1/2. The plus sign in front of the 1/2, don't just write 1/2 and assume that it's positive. It's sort of like the charge on an ion. I need to see the plus. Okay, now with that being said, we now kind of have our rules for our quantum numbers. So what we'll do is look at a orbital notation and practice going through our quantum numbers. Alright, so if I have an orbital notation for, let's just do the whole thing for oxygen. 1s, up, down, 2s, up, down, 2p. Right, there are 4 in here. 1, 2, 3, 4. And they fill in that order. It is imperative at this point in time that you pay attention to the order that you fill your electrons. The first electron that we put in was this first up arrow in the 1s, and then the down arrow in the 1s, 1, 2. The up arrow in the 2s was the third one, and the down arrow in the 2s was the fourth one. The up arrow on the left-hand side of the 2p was 5, this was 6, this was 7, and then we came back and did 8. Pay attention. If you need to number them, do so. I kind of stagger the numbering. I do the ones where the arrows point up a little higher, and the ones where the arrows point down a little lower. Alright, so we have a total of 8 electrons. So there are 8 electrons. Each electron has its own set of quantum numbers. Alright, so what I'm going to do is set up a little column. We have electron 1, 2, 3, 4, 5, 6, 7, and 8. Alright, we'll take a look at your very first electron. It is this one right here. Now, it is in energy level 1. So this first quantum number refers to energy level, so its first quantum number is 1, comma. The second quantum number refers to the sublevel. It is an S. All S's are assigned a number 0. The next one has to do with the number line. Where is it? Well, there's only one orbital, so there's only one number it could be. That's the center of the number line, which is 0. And that arrow is pointing up, so it's a plus 1/2. There we go. Alright, so quantum number 2. It is the one directly next to it. It's pointing down. Energy level is still a 1, so the first number is a 1. It's an S, which makes the second number a 0. The number line number is also a 0, and it is pointing down, which makes it a negative 1/2. Alright, the quantum numbers for electron number 3 are now, we move over. Energy level is 2. It's an S, which is assigned a 0. The number line is also a 0 for the third number. It's a plus 1/2. 4 is very similar. It's 2, 0, 0, negative 1/2 is pointing down. Alright, now when we get into the next one, we have electron number 5. Energy level is 2. It's in the P. P was assigned number 1 for sublevel. Now look at where he is located. We're talking about this electron right here. So if you have a number line of 0, 1, and negative 1, then he is at negative 1 on the number line and a plus 1/2. And we have 2, 1, 0, plus 1/2. And then 2, 1, 1, plus 1/2. And then 8 comes back and is pointing down. So it's at 2, 1. It's at the negative 1 spot, but it is at the negative 1/2. Alright, notice that all of these numbers are unique. Meaning, they're all 4 of them, there's no sets, so all 4 of those numbers are exactly the same. Okay, that has a special name. I will give it to you tomorrow in class.